everyone, today in Integrated Math 2, we're going to go over Chapter 9, Lesson 2. Here are the objectives. Make sure you write them down in your notes. Alright, first thing we want to go over is similar polygons. Similar polygons are when we have two polygons that are similar if and only if their corresponding angles are congruent and corresponding side lengths are proportional. So in our example here, we have our two polygons. We have this polygon ABCD, and we have polygon WXYZ. Based off of the markings that they have here, we know that angle A is congruent with angle W. We also know that angle B is congruent with angle X, angle C is congruent with angle Y, and angle D is congruent with angle Z. So that's the first part. The next thing that we want to find out is if they have corresponding side lengths. So in our case, we have AB, which is 15, and WX, which is 5. So I'm going to write that down, 15 and 5. And we'll go back to that at the end. Then we have BC and XY. So we have 12 and 4. Then we have CD and YZ. So 21 divided by 7. And then we also have AD divided by WZ. So 18 divided by 6. So let's check this out. 15 divided by 5 is 3. 12 divided by 4, that's also 3. 21 divided by 7 is 3. And 18 divided by 6 is 3. Which is equal to 3 over 1, because 3 over 1 also reduces to 3. And the way that we're going to show that polygons are similar is that sideways S. So this is a symbol for similar. And there we go for this one. Alright, next we have the ratio of the lengths of the corresponding sides of two similar polygons is called a scale factor. Very important. The scale factor depends on the order of comparison. So here we have our triangle ABC and triangle XYZ. So what they're saying here, keep in mind when we're talking about the scale factor and they're already saying something is similar, we need to go by the order that they're saying. Because what they're saying here is triangle ABC is similar to triangle XYZ. So A needs to correspond with X, B needs to correspond with Y, and C needs to correspond with Z. So with that, let's check out what we have. So remember, for scale factor, we want to see if we have corresponding sides of our similar polygon. In this case, so like we talked about, the order does matter. So what we have here is the length of AB. So AB is right here, which means X and Y are what we're comparing it to with the sides. So AB, so we have AB, and we're going to divide that because we want to find our scale factor, and we're going to divide that by XY. In this case, it's going to be 3. So then we put our letters first, XY. AB we said was 6, and XY is 3. 6 divided by 3 is 2. So our scale factor is going to be 2. But let's say we're doing our scale factor from our smaller triangle to our bigger triangle. So remember, what we do know is XY and AB. So XY, we're going to divide it by AB. XY is 3 and AB is 6. We can simplify this some more. They can both be divided by 3 So 3 divided by 3 is 1. 6 divided by 3 is 2. So our scale factor, when we're going from our smaller similar polygon to our bigger similar polygon, is a scale factor of 1/2. Then we have our theorem, perimeters of similar polygons. If two polygons are similar, then their perimeters are proportional to the scale factor between them. So our example is saying if A, B, C, D is similar to J, K, L, M, then we can also say that AB plus BC plus CD plus DA can be divided by JK plus KL plus LM plus MJ. And we can rewrite this even to be AB divided by JK and BC divided by KL, and CD can be divided by LM, and then we can divide AD by JM because the scale factor is the same between them all. And there we go.